1. This is on, again, page 186. So this is going to be derivative of that. It's going to be cosine x. And this is going to be negative sine x for that, so minus sine x. We set that equal to 0. I add a negative sine x to both sides. And then use the cosine of x equals the sine of x. And you know the cosine of x and the sine of x are the same at 45 degrees, or pi over 4 radians. So, critical numbers are representing something that's not. So pi over 4 there. And the other one, they're both positive in the first quadrant, and they're both negative in the third quadrant. So they're going to be equal to each other in the third quadrant. So, in the third quadrant, it's the 180, or 2 pi, or pi rather, plus pi over 4, and that'll give you 5 pi over 4 for the second critical number. Okay, so let's find the critical points then, using these values right here. You want to find the y for these two x's. So this will be the sine of pi over 4 plus the cosine of pi over 4. Type that out in your calculator, you get 1.41. And so that means that critical point is going to be pi over 4. 1.41. Do it again. For 5 pi over 4, sine of 5 pi over 4, plus the cosine of 5 pi over 4, equals, and that turned out to be a negative 1.41. So, the critical point here is 5 pi over 4 is your x, and your y is negative 1.41. And again, these are maybe relative minimum or maximum, depending on what's going on with the intervals. What intervals, you say? Oh, let me show you. So the first interval now is going to go from the 0, the lowest point of the overall interval, to the lower of the two numbers here, which is pi over 4. So 0 to pi over 4. Okay, so now I want to find out my slope in something in between. There's no known quantity that I'm aware of. Well, I guess I could have picked pi over 6, but I picked pi over 8, I think, when I did this work. So I'm going to test pi over 8. Have to use the calculator anyway. So this is going to give me, now I'm using this right here to see what my slope is going to look like for this area. So the cosine of pi over 8 minus the sine of pi over 8 equals, and I get 0.541 for that. So that means this is increasing. Okay, so to know what's going on with this first critical point, I have to look at the second interval, which is from pi over 4 to the next higher number, 5 pi over 4. So I'm going to test pi, because it's easy. Punch in my calculator. So cosine of pi minus sine of pi, and that equals -1. And that means it's decreasing, which I kind of suspected, but just to make sure we had to work it out. So that means then that my first critical point, the slope is increasing and then it starts to decrease, so at the very point where it changes, that's going to be its maximum. So that's going to be a relative maximum. So the odds are this is a relative minimum, but we got to prove it here. So let's find out. We go to the last interval, I3, which is going to be from 5 pi over 4 to 2 pi. And I picked 3 pi over 2 as being somewhere in between those, so it doesn't make a difference long as between 5/4 and 2 with the pi line. So I'm going to test, pi test, I'm going to test 3 pi over 2. So this is going to be the cosine of 3 pi over 2 minus the sine of 3 pi over 2. And that value equals 1. And that value is increasing because it's positive. And so it's exactly what I thought was going to happen here. It's decreasing, and then it starts to increase. So that point where it changes, the critical point, means it is a relative minimum. So, same process before, just a limitation with your interval for the problem. Okay? So, your assignment, page 186, problems 40 through 46. I'll put that page here. Page 186, 40 through 46 even. Have fun.